Okay guys, so this is section 9, topic 8 on the empirical rule. So what the heck is an empirical rule? I'm glad you asked. So assume that, we're going to dive into that. So assume that we have a data set so large that we are not given a list of all the values. We are told the data follows a normal distribution. What does a normal distribution mean again? You're right, it's a bell curve. So it goes up and then comes back down. Everything is balanced the way it should be with the mean and the median both in the middle. So this normal distribution has a mean of 16 and a standard deviation of 4. We're going to label the distribution with the values using the mean and the standard deviation. So where should the mean go? So you see all these little tick marks? They represent numbers. So where do you think the mean should go? You're right, the mean should go in the middle. So the middle of this data is going to be right here. It's at the top of the bell curve, so that's my mean. And then the standard deviation of 4 means that's how far away each one of these tick marks are. So 4 up from 16 would be 16, 17, 18, 19, 20. So that would be 20, and then 24, and then 28. Then if we go to the left, we're going down 4. So we're at 16. 16 minus 4 is 12. And 12 minus 4 is 8. And 8 minus 4 is 4. Okay, so suppose one of the data values is 20. An observation of 20 is how many standard deviations above or below the mean. So 20 would be one standard deviation above the mean. Suppose one of the data values is 8. An observation of 8 is, well, here's my mean. I'm going to circle it so we remember that that's the mean. And my mean, 8 is 2 standard deviations below the mean. Okay, so suppose an observation is 1.5. The observation of 1.5, suppose an observation is 1.5 standard deviations above the mean. So there's 1.5. So if I'm halfway between 20 and 24, that's going to be at 22. So that observation is, so that observation is 22. Okay, we can use the empirical rule to understand data distribution. So the empirical rule has a lot to do with percentages, and really it's just a rule of memorization here. So the empirical rule states that approximately 68% of values are within one standard deviation of the mean. So within one standard deviation is 68%. That's important. Approximately 95% of the data, let's do this, fix it for a second. Okay, approximately 95% of the data, or percent of the values, are within 2 standard deviations of the mean. And approximately 99.7%, almost 100%, are within 3 standard deviations of the mean. So now we're going to label these percentages on the previous distribution. So I'm going to show you this. You can see them both at once on yours. Let's see. I can show them both. Let's do this. So let's use these percentages that we just learned to label this data distribution a little more clearly. So remember, 68% is within one standard deviation of the mean. So 20 is within one standard deviation, and so is 12. Both of these are either one standard deviation above or one standard deviation below. So this section of data, from here to here, represents 68% of the data. So from 12 to 20 is 68% of the data. Now, the second statement in the empirical rule is that 95% of values are within 2 standard deviations of the mean. So 2 standard deviations would mean 2 above, so that would be to 24, and 2 below, which would mean to 8. So all of the values between 24 and 8, or within 2 standard deviations of the mean, are 95, that's 95% of the data. And then finally, 99.7% of the data is between, in a normal distribution, just draw these all the way down so we don't get confused as to where they're going from, when they're coming from. 99.7% of the data is within 3 standard deviations of the mean. So that's 1, 2, 3 below, 1, 2, 3 above. So that's 99.7% of the data. Almost all of the data is within 3 standard deviations of the mean if it's a normal distribution. So 99.7% of the data. Okay, so make sure you label yours just like this. If you need to pause to do that, then go right ahead. All right, moving right along. So let's practice. Let's apply this. Suppose the amounts of water in a machine dispenses into plastic bottles has a normal distribution with a mean of 16.2 ounces and a standard deviation of 0.1 ounces. So we're going to label this with the values using the mean and standard deviation. So it has a mean of 16.2, that goes in the center. And then a standard deviation of 0.1, so that's 0.1 above, 16.3, 16.4, 16.5, and then 0.1 below, 16.1, 16.0, 15.9. And then we need to go ahead and label using the empirical rule. Let's go ahead and label. So 1 below to 1 above is 68% of the data. 2 below to 2 above is 95% of the data. And then 3 below to 3 above is 99.7% of the data. So let's fill it in. Sorry guys, it's not focusing very well at the moment. There we go. Okay, so the middle 95% of bottles contain between blank and blank ounces of water. That would be between 16.0 and 16.4 ounces of water. Approximately 68% of bottles have between blank and blank ounces of water. Well, that 68% is that very, very middle section of the data with within 1 standard deviation of the mean. So that would be 16.1 and 16.3 ounces of water. What percent of bottles contain more than 16.4 ounces of water? So, the percentage of bottles that contain more than 16.4 ounces of water are, so I'm really just looking at this section right here. So we know that the percentage of bottles that contain more than 16.4 ounces of water are, so we know that 95% are between 16 and 16.4. So that means that the other 5% are either less than 16 or greater than 16.4. Well, because it's a balance, that means that that 5% is split. There's 5% that are less than 16. There's 2.5% that's less than 16 and 2.5% that's greater than 16.4. So the 2.5% here and the 2.5% here add up to give me the rest of that one, add up to give me that 5% that makes up the rest after the 95%. So next we have, what is the probability that a randomly selected bottle contains less than 16.3 ounces of water? So 16.3 ounces is here. So the probability that it contains less would be all the way up to this 68%. Okay, so if it contains less than 16.3, that means it's up to this point and below. So we know we have at least 68% that's less than 16.3, plus we have this extra that's less. Now, just like we did with the 2.5% here and here, we know that what's left after this 68% is 32%. So we know that there's 32% split between this section of the data all the way up to 100% and between this section of the data all the way down to 0%. So 100 minus 68 gives me that 32. And then I have to take the 32 and divide it by 2 so that I know what's on both sides of that data. So 16% is here and 16% is here on either side of that 68%. Now we still have that original 68% plus the 16% from the lower side because we know that it's less than 16.3. So 68% plus 16% is 84%. So the probability that a randomly selected bottle contains less than 16.3 ounces of water is 84% or 0.84, however you'd like to write that. So then last question on the Let's Practice, what percentage of bottles contain between 16.1 and 16.4 ounces of water? Now this one's a little bit more tricky because we know that it's at least 68%, and we're going to have to add something to it because 68% is between 16.1 and 16.3. Now to get this last 0.1% right here, I have to figure out from this 95% to 68%, how much did it go up? So 95 minus 68 is 27. Sorry guys. So it's 27, and then that 27 is split two ways. So the 27 divided by 2 gives me 13.5. So I have 13.5 right here and 13.5 right here to add to that 68. So I have 68 plus 13.5 gives me 81.5%. So that's 81.5% that is between 16.1 and 16.4. Okay, so one more time just to recap. This 68% came from between 16.1 and 16.3 is 68%. And then we had to compare to this 95 to figure out what was here in this section and here in this section. So 95 minus 68 gave me 27. I divided that by 2 to get the 13.5 that was here and here. And I'm really just looking from 16.4 down to 16.1. So that is the 68% plus the 13.5% gave me the 0.5%. Okay, let's go on to the try it. Choose the correct numbers to build a normal distribution graph based on a mean of 45.5 and a standard deviation of 3.92. All numbers will not be used, and some may be used more than once. So my mean is right here. That is my 45.5. So that would be this one. And then my standard deviation is 3.92. So I'm going to add 3.92 to 45.5. And that gives me 49.42 would go here. And then add 3.92 again. And that's 53.34 would go here. And then I'm going to subtract 3.92 from 45.5 to go down. So 45.5 minus 3.92, 45.5 minus 3.92 gives me 41.58 is one standard deviation below the mean. And then I'm going to subtract 3.92 again. and I get 37.66 is 2 standard deviations below the mean. All right, so now we have the mean and we have the standard deviations below and above. Now I'm filling in the percentages. Now remember, empirical rule tells me that within 1 standard deviation of the mean, 1 below and 1 above, is 68% of the data. And within 2 standard deviations of the mean, 2 below and 2 above, is 95% of the data. Now, let's look at these sections. So this refers to from here to here. Now, this section is half of this 68%. So half of 68% is 34%, and the other half is also 34%. And then these leftover sections from here to here and here to here are the difference between the 95% and the 68%, in the same way as what we found down here, where we said the 95 minus the 68 gave me 27. And so if there's 27% left over, but it's split into 2 different sections, we take the 27, divide it by 2, and get 13.5. So this is 13.5%, and this is 13.5% as well, to add back up to that 95% from the 68. All right, last part, beat the test. So, for the beat the test, it says, SAT mathematics scores for a particular year are approximately normally distributed with a mean of 510 and a standard deviation of 80. What is the probability that a randomly selected score is greater than 590? So we need to draw a standard distribution, or we need to just map out this data. So with a mean of 510, so I am going to draw this out down here. I think it would help a little bit to just kind of have a visual with this. Might not be perfect, but we could just kind of draw it out a little bit. So the mean is 510 and a standard deviation of 80, which means that 1 above is 590, 1 below. If I take away 80 from this, I take away 10, so there's 70 left, so that would be 430. And then 80 more, so 590 plus 80 would be 670. This is my mean, I don't want to forget where it is. And then 2 below, 430 minus 80 would be 350. So then I know the probability that a randomly selected score is greater than 590. So I know from 510, I know between 430 and 590 is 68% of the data. Okay, I know that between 350 and 670 is 95% of the data. And then let's go one more out here and one more out here. So between 350 minus 80, which is 270, and 670 plus 80, which is 750. Okay, between those is 99.7% of the data. Okay, so the probability that a randomly selected score is greater than 590 would be from here to here. Now, I know that this section right here, we just figured out is 13.5% because it's that difference in the 95 and 68 divided by 2. And then this section right here, and then this section right here is 2.5% because this 100 minus 95 leaves us with 2.5% here and 2.5% over here. So then to get the probability that a randomly selected score is greater than 490, I'm adding the 13.5% and the 2.5% to get 16%. Or 0.16, however you want to put that for probability. It's either a percentage or it's a decimal between 0 and 1. So then what is the probability that a randomly selected score is greater than 670? So 670 is here. So the probability that it's greater than 670 is 2.5%. We just used that to help us find the first one. Or if we want to write that as a decimal, be careful. We're moving the decimal 2 places to the left, which means as a decimal, that would be 0.025. Not 0.25, but 0.025. Okay, so last two parts and then we're done. What percentage of students scored between 350 and 670? So between 350, that's down here, and 670, that's up here. Well, that's easy because our empirical rule says that 2 standard deviations below and 2 standard deviations above is 95% of the data. So that is already labeled for us as being 95%. So 95% of students scored between 350 and 670. And then a student who scored a 750 is in the blank percentile. So a student who scored a 750 is in the blank percentile. So let's look at this a little closer. So if they scored a 750, they are not just in the 99.7 percentile because we do have a section of data that's back here before we start from 0% all the way up. Now, if we have 99.7, there's still 0.3 out there that's missing. 100 minus 99.7 is 0.3. That 0.3 is split, and 0.15 of it is below the 270, and 0.15 of it is above 750, or 15%. So there's 15% below down here. So we have the 99.7 that we already know about plus 0.15. And together that gives me 99.85. So a student who scored a 750 would be in the 99.85th percentile. All right, that's it. If you have any questions, let your teacher know.